Okay, now hope you understand to draw the circuit diagrams. Now here, according to the activity 10.3, if you switch on all three at once, okay, it is clear that the brightness of the bulb decreases with the increase of bulbs connected in series across the voltage supply. But the initial brightness can be obtained by increase the number of cells. Thus, the several low voltage bulbs can be lit from this high voltage supply when they are connected in series. Okay, so now here the cell systems are series. Now, for an example, here the brightness will be with the 1.5 voltage supply. Okay, now here 1.5 voltage supply will be supplied for the two dry cells. So the brightness will be less. Okay, less brightness will be showed in this circuit. So here again there are two dry bulbs are connected now. So if you increase the cell, one more cell, what will be there? The brightness will be increases with the low voltage, the high voltage supply. Okay, so that's what they have said here. The brightness of the bulb decreases in the first one with the increase of bulb connections, the bulbs connected in the series across the voltage, same voltage supply. So when you increase two bulbs, the brightness will be less. Okay, but the initial brightness can be obtained by using the number of increasing the number of cells. So if you increase the number the cells by another dry cell, so the initial brightness can be obtained. So this and this one will be the same. Okay, this one and this one will be same because two dry cells and two bulbs, here one dry cell and with one bulb. So the thing, the voltage supply will be equal. Now parallel bulb. Now we are going to see parallel bulb system. The series bulb system, now we saw that parallel bulb system. So activity, yes, activity 10.4, 6 filament bulbs will be needed, 2.5 voltage each, and 3 dry cells will be needed, 1.5 voltage each, and 3 switches will be needed to construct all 3 circuits. First method, connect one bulb to a cell and a switch as shown in the figure 10.14, and the second one, two bulbs connected parallelly with the same circuit. Okay, here they have increased the number of bulbs, 3 bulbs connected parallelly with one dry cell with a switch. Okay, so if you draw the circuit diagrams for these children, one bulb, switch, positive terminal, negative terminal. Got it? Okay, the second one, children, the bulbs should be connected parallelly. The bulbs should be connected parallelly. Here you see a switch and one dry cell, and this one will be the circuit number, the circuit of figure 10.15, and circuit of figure 10.16 is like this: one bulb, two bulbs, three bulbs, those are connected parallelly and will be connected to one switch and a dry cell. The dry cell has connected positive terminal and negative terminal as I drawn. Okay. Now you understood to draw the circuit diagrams now, huh? Okay. Now switch on all three circuits at the same time. Observe the brightness of the bulbs. Discuss with your teacher the connection, the conclusions that you can make according to the observations. The brightness will not the brightness will not significantly change even though the number of bulbs connected in the parallel are increased. Okay, they all will light with this almost the same brightness. Say they all light with the same the brightness. Okay, now but can you see now, you see, they have even though they have connected one bulb with one dry cell, or two bulbs with one dry cells, even though they connected three bulbs with one dry cells, all are same. They will be light up with same brightness. Understand, children? So all three are in same brightness. So and also we saw, if they have connected the the parallel cell system also the same, no, the parallel cell system also the same brightness will be received. Okay, now these are the circuits and the activities about the brightness of the bulbs and the cells when you connected parallelly and see in series manner. Okay, so keep it in your mind. They will give you in MCQs and some other questions also to compare the brightness. Okay, which is brighter. Okay, so for those things you have to keep it in your mind, the way in which way will be getting the same brightness, and which way you will be getting the more brightness or less brightness, likewise you have to memorize that. Okay, now we are moving to 10.2, simple electric circuits. Okay, electric torch. So you have seen the electric torch that you are using when there is a power cut you are using, and when you want to see something brighter, so you're using an electric torch. So electric torch is an essential equipment when we are going when we are going in dark at night, and when we are in search of something in dark. There are electric torches with only one dry cells with several dry cells are connected in series manner. So the figure 10.17 shows such an electrical torch. Okay. Now can you see this? The parts. Will see the parts. Okay. Now these are the two dry cells. Can you see the dry cells here? Here. These are the two dry cells. You see the positive terminal. Always the button like point will be the positive terminal, and this one will be the negative terminal here. So the negative terminal of one dry cell is connected with the positive terminal of the other dry cell. So which method the dry cells are connected now? Series, in series manner. Okay, so the positive terminal is connected with the previous one's negative terminal. So this is the series cell system, series cell system. So two dry cells connected in series, and metal stripe is there. Have you seen the spring like metal stripe is there in the torch? On the lid of the torch, sometimes you may see the metal spring. Okay, the metal spring is there. uh, so that is the metal spring will be connected. You can't see, but inside it will be connected to the switch here. Here see the switch. So when you this part and this part will be connected when you push this switch forward. when you push this switch forward, this part will be connected here and this part will be here. So at that time this bulb will be on because there will be a closed circuit. There will be what? A closed circuit will be there. Yes, there will be a closed circuit arising there. So because of that, the current will be flow through the closed circuit when you switch on the push this switch forward. Okay. Now the metal springs, the other part, connectors, the conducting connectors, these are called conducting connectors. So these also conducting connectors are here. It's attaching, joining here in this part. Okay, so here is the bulb, so the bulb will be light up. And the reflector is there. Have you seen, inside the torch there will be a silvery color reflector is here. Why is that silver color reflector is there? Why, if it's not there, what will happen? So because of the reflector, the light will be reflecting more. Okay, because of the reflector also the light will be reflecting more, and will be, because it can be reflect. Okay, so can you remember the concave mirror? Concave mirror we have studied. Okay, the light which is falling on the concave mirror will be collected to a spot. Can you remember? Collected to a spot. So here the light which is emitted by the bulb will be reflecting by this concave surface. There are two concave surfaces are there. So it will be also useful to get more light if there is a reflecting surface. Concave reflecting surfaces are there. As shown in the figure, dry cells, bulbs, metal spring, and the connecting conductors of this torch are connected with each other, but the circuit is open because of the switch. Therefore, the bulb does not light when the switch is pushed forward. I said already, the gap between the conducting connectors is connected closed and the bulb is lit. Okay, using a circuit symbols, assignment 10.1 I'm reading. Using the circuit symbol for bulb, electric cells, switch, bulb, electric cell, switch, and connecting wires, draw a circuit diagram for the electric torch of figure 10.17. Explain the advantage of using the reflector in an electric torch. Okay, reflector. Okay, I said now if you draw the circuit diagram. Okay, here see the bulb is there. Okay, the bulb is connected with what? Connecting conducting connectors. Here is the switch, and after that, here here is the uh, positive terminal and the negative terminal. Positive terminal and the negative terminal. Here is the circuit symbol, the circuit diagram of this. Okay, now you can draw like this also, no problem. Here you can draw like this also, it's also okay, no problem. And here see light decoration. This is the second instance where we are using the simple electric circuits. The simple electric circuit we use in electric torch, first one, and light decorations. You may have seen that light decorations are used to decorate various ceremonial occasions in a wedding, or else a Christmas tree, or else in some Christmas parties, and some other occasions also we are using the light decorations. So activity 10.5, to make light decorating circuit. So for this you will be needed power supply of 6 volts, or 4 dry cells, 6 colored LEDs, 2 red, 2 blue, and 2 green LEDs, and connecting wires, copper strips will be needed. The method: draw a diagram for the circuit shown in the figure 10.18 and indicate where the switches should be connected to light blue LEDs only, red LEDs only, green LEDs, and both blue and green LEDs at the same time. Make the circuit on the board and take all switches to one place of the board and supply power to the circuit by opening and closing the switch. Try to build a simple pendle. The pendle, Vesak pendles are there. Have you seen the Vesak pendles? They are, emitting lights with the LED bulbs with different different colors and different different designs. So at the same time, it won't be lighting up at the same time. It's different different time limits are there to make a decorative lights. Okay, so what they are asking you to do, first of all, you have to draw this figure 10.18. You have to draw. Now there are 4 dry cells are connected in series manner, and here see, uh, the blue bulbs, green bulbs, and blue LEDs, green LEDs, and red LEDs are connected in the parallel manner, but blue bulbs are connected series, among them, but each of the colors are connected in parallel manner. So how do you draw the circuit diagram for this? So the circuit diagrams will be like this here. So do you know the circuit symbol for the LED? LED circuit symbol is like this. This is the diode. This is the what do you call, the symbol for the diode. This is the symbol for the LED, light emitting diode. Light emitting diode. Okay, now light emitting diodes, positive terminal is this, negative terminal is this. Okay, now children, when you draw the light emitting diode here, LED here, so you want to draw the LED like this. Okay, that one is the blue one. This one will be the green one. This one will be the red LEDs. If you not indicating the arrows, it means it's diode. Okay, light emitting diode only. Okay, now the dry cells. So negative terminal and the positive terminal. So first you have to draw the negative terminal and positive terminal. Here negative terminal and positive terminal. Here negative terminal and positive terminal. Here negative terminal and positive terminal. Hope you understood, children, to draw the circuit diagram of this figure 10.18. Okay, now what they are asking you to do, here see, this is the task. This is your task. So they are asking, indicate where the switches should be connected to light bulb blue LEDs only. Okay, light blue LEDs, only red LEDs, only green LEDs, and both blue and green LEDs. So this one is 1, 2, 3, and these two 4. 4 tasks are there. Okay, now this is the blue. So they have to, they are asking you to do, here see, first of all, light blue LEDs. So to light blue LEDs, where should you keep the switch? Okay, now if you keep a common switch, what will happen? Commonly all the LEDs will be light up. So you have to keep a, you know, you have to keep a particular switches for each LEDs. So for that, what you have to do is you have to keep the right. You have to keep the switch here. Okay, the switch here. And if you light up the red LEDs, you have to keep the switch here. And if you want to light up the green LEDs, you have to connect the switch here. Okay, if you want to light up the blue and the green LEDs, both should be blue and the green LEDs together. So both should be closed, this one will be open. Okay, now this is how you have to connect. Now make some light decoration circuits using dry cells, LED switches, and connecting wires. Get the assistance of your teacher. So decorations also can be done here. See, so if you want, the second task is what? Make the circuit on a board and take all the switches to one place of the board. So supply power to the circuit. So you can, if you are making this pendle in a board, children, take a rigiform board and make this circuit as it is, and the switches, you have to take the switches in one place. So switches, if you take it one place, so you can on and off the same thing, if they want the decorative lights, if they want to use at the same times only one should be, so you have to close and open. So at that time it will automatically give the same, the whatever you want according to your requirement. Okay, we'll move to the 10.3 current controlling components, which is important. Current controlling components. On various occasions, it is necessary to control the amount of current flowing through an electric circuit. There are several components that can be used for this purpose. We can use those components according to the situation. So let us consider how some of such components can be used. So the first one is switches and keys. Switches and keys. Switches or keys are used to turn on or turn off the electric current flow through a switches or keys are used. Turn on or turn off an electric current flow through a circuit when necessary. There are various types of keys. Some simple keys are mentioned below. So let's see. This is one of the simple key. Tap key. Okay. Tap key, the diagram of a tap key is shown in figure 10.19. P and Q are terminals connected to the circuit. Here see, this is the tap key. Okay, tap key. So here are the parts. The P and Q are the terminals connected to the circuit. These are the terminals connected to the circuit. Okay, the P and the Q are the terminals connected to the circuit. When the B end of the metal strip is pressed with your finger, X and Y ends connect each other. Okay, now when you press this, by your finger, B, if you press with your finger, what will happen? The AB, the stripe AB will be lower and B will be connected with this Y. Okay, so when B end of the metal stripe is pressed with your finger, X and Y ends connected. X and Y, here see X end and this is Y end. X and Y are ends connect each other. Okay, then the circuit between P and Q is completed. So if this is connected, what will happen? It's completed. So the switch is completed and there will be a flow of electric current. When the finger is released, B end of the AB metal strip lifts up as a spring. Okay, so when you press only, it will be touching here. When you leave the finger, if you leave the finger, it will be if you leave the finger, what will happen? It will be coming to the resting point. Okay, so for an example, you can give an example. Where are you doing this type of connection? So when there is a doorbell, have you all seen the ringing bell near the door? So when you press only, the doorbell will be working. When you leave the finger out, if you lift the finger from the switch, it will be stopping. It will stop ringing, isn't it? So uh, when the finger is released, B end of the AB metal strip lifts up as a spring. Hence, circuit is disconnected. This is called one-way tap key because it is used to let the current to flow one direction only. Okay, so this type of switches we called as one. Okay, how do you call this is called one way tap key. How do you call one way tap key? Because it allows to flow the electric current in one way only. Okay, so what is the example? The electrical doorbells. Plug key plug key this is you can examine the diagram of a plug key is shown in the figure 10.19. P and Q are terminals connected to the circuit. P and Q are the terminals connected to the circuit. So this is the terminal and Q is another terminal. Like the terminals in the dry cells, terminals in the bulbs, terminals of the LEDs. Likewise, here are also two terminals. Okay, so there is a gap between the metal block made of brass. When the plug rod is inserted into the hole between the gap, the circuit is closed. When the plug rod is removed, circuit is disconnected. Now, have you all seen, like, the pushing a switch, and after that again push and release to off the switch? Okay, so those type of the switches also there in our day-to-day life. We have day-to-day life we have come across those type of switches. Okay, imagine what I am saying. When you push and leave the finger, it will be on. Again you have to push and lift the finger up, so away, so then it will off. So these type of plugs we called as what? Plug key. With these type of switches we called as plug key. So when the plug rod is removed, circuit is disconnected. When here see, when the plug rod is inserted into the hole between the gap, the circuit is closed. When the plug rod is removed, the circuit is disconnected. So there are two keys we have studied. What? Tap key and the plug key, and the other one is permanent resistors. So through the plugs, the keys also we are controlling the current. Now, if there is no keys, no switches, how can we control the current? Whenever we don't want the current supply, we can off if there is a switch. If there is no switch, waste of current. So so that is also one of a current controlling component. So permanent resistors, obstacle to flow electric current through a conductor is known as resistance. We have already done this, children, in part 1 electricity. We have know these terms and with the definitions. What do you mean by resistance? The obstacle to flow an electric current through a conductor is known as the resistance. Components that have property of resistance are known as components. Components that have the property of resistance are known as resistors. So copper wires are used to connect circuits because their resistance is very low. So copper wire is a good conductor of electricity also, because what is the reason for to be a good conductor? Because their resistance is very low. So resistance of wire made of nichrome and manganese are very high. The resistance of the conductor nichrome and manganese is very high. Therefore, wires made of metals like nichrome and manganese are used to make resistors. So, what are the components used to make resistors? What are the elements? So, what are the elements used to make the resistors? Nichrome and manganese. Okay, so there are resistors made to certain fixed values in the laboratory. They are known as fixed resistors. I have showed these children these type of resistors. I have showed these to you all in our classroom. So these are called fixed resistors with different value of resistance. Okay, so for an example, this type of resistance have 2 ohm. So ohm is the unit used to measure the resistance. Okay, here this resistor is containing 5 ohm. Okay, now every electric component has an exact resistance value. Therefore they also use to be controlled, considered as a permanent resistors, because every resistors are having a the fixed value of them. So likewise, 2 ohm, 5 ohm, 10 ohm, 15 ohm, 20 ohm, likewise it will goes on. So those are also considered as permanent resistors. Now come to activity 10.6. Now for this activity, what are the things will be needed? A permanent resistor of 2 ohm, a permanent resistor of 5 ohm, a filament bulb of 2.5 volt, 2 dry cells, an ammeter or millimeter, a switch, connecting wires will be needed. So the method, connect the bulb, the switch, the ammeter or millimeter and the dry cells as shown in the figure 10.21. Okay, so in 10.21, how do they have connected? Here see, the voltmeter or else millimeter or ammeter, sorry, not voltmeter, millimeter or ammeter, bulb, two dry cells and a switch. Okay, now close the switch and record the ammeter reading. Observe the brightness of the bulb also. Then connect the extra fixed resistor of 2 ohm to this circuit as shown in the figure 10.22. So first of all we have to draw this circuit diagram for these children. So how do you draw the circuit diagram? Here see, ammeter or millimeter both are same symbol A, capital A in a circle. Okay, and here is the bulb, here is the same, it's series, no, however it's series. So positive terminal, negative terminal, positive terminal, negative terminal, and the switch. Okay, this is the figure 10.21 and the figure 10.22 is like this. The same thing, ammeter, a bulb and two dry cells, positive terminal, negative terminal, positive terminal, positive terminal, negative terminal, and the switch. The switch and the resistor. The resistor of 2 ohm, 2 ohm resistor. Okay, now you understood children how do you draw the circuit diagram with the symbols. Close the switch and observe the brightness of the bulb and record the ammeter reading. Okay, so here see, if you record the ammeter reading it will be showing the electric current flowing through this circuit, no? So after that, open the switch of the circuit shown in the figure 10.22 and replace fixed resistor of 2 ohm and after that 5 ohm and 2 ohm. Close the switch again and then observe the brightness of the bulb and record the ammeter reading. So first of all the 2 ohm resistor it seems, second 5 ohm resistor, 5 ohm resistor you have to connect and after that you have to check the ammeter reading. So what do you think children? Here see, two dry cells are connected with an ammeter and a bulb without no current controlling components. So it will be showing according to the according to the way that they have supplying current by two dry cells. And here if you connect the resistor of 2 permanent resistor, fixed resistor of 2 ohm, the flowing through that circuit will be less or more, because there is a resistor. There is an obstacle for an electric current. So if you connect the 2 ohms, will be the brightness of the bulb will be decreased a little bit. If you connect 5 ohms resistor to the circuit, it will decrease more, because there is more obstacle is there. There is a relationship between the resistance and the current flowing. We have already studied in part 1 book. What is the relationship? If there is if the resistance is high in the circuit, the current flowing will be low. If the current flow will be high, resistance will be low. Okay, so resistance is controlling the current flow. So okay, so that is the obstacle to the flow of current. Instance, brightness of the bulb and the ammeter reading. Without permanent resistor, ammeter reading will be high. The brightness of the bulb will be brightest. Okay, so bright. So mm, bright. Ammeter reading will be high. Okay, here permanent resistor. If you connect a permanent resistor, okay, less bright. Low. Okay, if you connect the uh, 5 ohm resistor, least bright, no, or else here low brightness will be low. Lower. Now when an extra resistor is connected, right, what are the conclusion that you can reach according to the observation, children? Okay, so if you connect the permanent resistor, that is also acting as the current controlling component. When an extra resistor is connected to an electric circuit, electric current flowing through the circuit is reduced. When the resistance of the circuit further the sorry the resistance of the circuit increase further, current flowing decreases. So therefore it is clear that the current flowing through a circuit can be reduced by connecting fixed resistors to the resistors to the to increase the resistance. Okay, so it is clear that the current flowing through a circuit can be reduced by connecting fixed resistors. Okay, so when you connect the fixed resistors to the circuit, there will be an obstacle to the current flow, and current flow will be uh, decrease.